Imagine harnessing the power of the sun right here on Earth. Sound like something out of a sci-fi movie? Well, it's closer to reality than you might think. Welcome to a world where the line between science fiction and science fact blurs. A world where we're on the brink of tapping into one of the most potent sources of energy known to humanity: nuclear fusion. It's the same process that powers our sun and all the stars that twinkle in the night sky. Now you might be wondering, don't we already have nuclear power plants? Yes, we do, but those operate on the principle of nuclear fission, not fusion. In nuclear fission, the nucleus of an atom is split into two smaller nuclei, releasing a significant amount of energy. But the process also produces nuclear waste, a dangerous byproduct that poses a significant environmental hazard. Nuclear fusion, on the other hand, is a completely different ballgame. It's the exact opposite of fission. Instead of splitting an atom's nucleus, fusion combines two light atomic nuclei into a single heavier nucleus. The result, an immense release of energy far more potent than anything nuclear fission can produce. But here's the kicker. Nuclear fusion produces virtually no long-lived radioactive waste. It's a clean green source of energy. Plus, the fuel for fusion, isotopes of hydrogen, are abundant and nearly limitless. We're talking about an energy source that could power our world for millions of years. Nuclear fusion has the potential to revolutionize our energy landscape, providing us with a cleaner, safer, and more sustainable solution to our energy needs. And the best part, we're not talking about a distant, far-off future. The dawn of fusion technology is upon us. While fusion power may sound like a far-off dream, it's not as distant as you'd imagine. So buckle up as we dive deeper into this exciting world, exploring the power of the sun right here on Earth. Fusion technology isn't just a concept, it's a field of active research and development with remarkable progress being made. We are witnessing the dawn of an era where the power of the sun is harnessed right here on our planet. The most significant advancement in the field of nuclear fusion is the development of innovative reactor designs. Scientists have been toiling away in laboratories, creating models that can withstand the extreme conditions necessary for fusion to occur. These designs are a testament to human ingenuity and perseverance, proving that we can recreate the intense heat and pressure found at the core of the sun. One of the most promising designs is the tokamak reactor, a donut-shaped vessel that uses magnetic fields to contain the hot plasma where fusion happens. This ingenious design allows us to control the high-energy particles, paving the way for sustained fusion reactions. Another breakthrough is the development of advanced materials capable of withstanding the extreme temperatures inside a fusion reactor. Materials like tungsten and beryllium are being explored for their ability to survive in the intense heat, ensuring the reactor's longevity and safety. In addition to reactor designs and materials, advancements in diagnostics and simulation technologies have been game changers. These technologies allow scientists to monitor and control the fusion process accurately, bringing us closer to achieving a sustained and controlled fusion reaction. But perhaps the most significant advancement is the international collaboration in fusion research. The ITER project, a joint venture involving 35 nations, is a testament to the global commitment to making fusion power a reality. This project aims to build the world's largest tokamak and demonstrate that fusion can be used as a practical source of power. With these advancements, we're inching closer to making fusion power a reality. The dawn of fusion technology promises a future where we can harness the power of the stars to light up our cities, power our industries, and propel us into a new age of energy production. Fusion power isn't just a dream, it's a future we're actively building. Ever wondered what goes on inside a fusion reactor? Let's dive in. At the very heart of a fusion reactor, a thrilling dance of atomic particles unfolds. This dance isn't just a mesmerizing spectacle, it's the very process that powers the stars, including our very own sun. It's called nuclear fusion, and it's all about merging or fusing lightweight atomic nuclei into heavier ones. But what's so special about this dance? Well, it releases energy, a lot of it. Imagine a party where everyone is moving so fast and with so much energy that when they collide, they combine to form a larger, more powerful entity. That's nuclear fusion in a nutshell. But unlike a regular party, this one's taking place at temperatures over 100 million degrees Celsius. Now, holding a party at such extreme temperatures might sound like a recipe for disaster. But here's where the brilliance of fusion reactors comes in. They use a device called a tokamak, a donut-shaped chamber that uses magnetic fields to keep the superheated plasma, that's the partygoers in our analogy, contained and away from the reactor walls. This ensures the party can keep going without causing any damage. The safety of fusion reactors is one of their most impressive features. Since the fusion process relies on specific conditions of temperature and pressure, any disturbance to these conditions causes the reaction to stop immediately. This means a nuclear meltdown, such as those seen in fission reactors, is virtually impossible in a fusion reactor. It's not just about safety, though. Fusion reactors are incredibly efficient. The fuel for fusion comes from two isotopes of hydrogen, deuterium and tritium, which are abundant in our oceans. A fusion power plant producing 1 gigawatt of power could operate for a year on just 18 kilograms of these fuels. Fusion reactors promise to revolutionize the way we generate power, offering a clean and nearly infinite source of energy. Fusion power isn't just about technological innovation, it's about shaping a brighter, more sustainable future. When it comes to environmental benefits, fusion power wins hands down. Traditional energy sources like coal and natural gas emit harmful greenhouse gases and contribute to air pollution. Even nuclear fission, which is relatively clean, produces long-lived radioactive waste. But fusion? That's a whole different story. Fusion power is clean. The process produces no greenhouse gases, and the only byproducts are helium, an inert gas we use in party balloons, and a neutron. This neutron is absorbed by the reactor's walls, creating no long-lived radioactive waste. Imagine that, an energy source that doesn't pollute our air or leave us with a waste problem for future generations to solve. Practically speaking, fusion power holds immense promise. The fuel for fusion is found in seawater and lithium, both of which are abundant on Earth. We have enough resources to power the planet for millions of years. Yes, you heard it right, millions of years. Now let's talk about climate change. It's the elephant in the room, isn't it? We're looking for ways to cut our carbon emissions, to slow the warming of our planet. Fusion power could be a game changer. It could provide us with the vast amounts of energy we need without contributing to climate change. That's a win-win, wouldn't you say? But it's not all smooth sailing. Fusion power is challenging to achieve. That's why it's been the subject of research for decades. But progress is being made, and we're closer than ever to making this dream a reality. The potential of fusion power extends far beyond the realm of science and technology. It's about envisioning a better world, a world where we meet our energy demands without compromising the health of our planet, a world where we leave a sustainable legacy for future generations. Yes, fusion power is more than just a technological innovation, it's a promise of a brighter, more sustainable future. So, when can we expect fusion power to light up our homes? Let's look at the road ahead. The timeline for fusion power becoming a reality is a topic of intense debate among scientists. Some are optimistic, predicting operational fusion power plants within the next couple of decades. However, others are more cautious, citing the many technical challenges that still need to be overcome. One of the most significant hurdles is achieving ignition, the point at which a fusion reaction produces more energy than is put in. This is a monumental task, akin to capturing a star in a bottle, and requires precise control of extreme temperatures and pressures. But the good news is, we're making progress. Around the world, international collaborations are pooling resources and expertise to conquer these challenges. The International Thermonuclear Experimental Reactor, or ITER, is a prime example. A joint venture between 35 nations, ITR is currently constructing what will be the world's largest tokamak, a device designed to contain superheated plasma long enough for fusion to occur. Then there's the National Ignition Facility in the United States, which uses powerful lasers to compress and heat a small pellet of fusion fuel. They've already achieved significant milestones, bringing us a step closer to unlocking fusion's potential. However, it's not just about the science. The transition to fusion power will also require massive infrastructural changes, rethinking our energy grids and navigating complex regulatory landscapes, not to mention the need for significant investment and public acceptance. But let's not lose sight of the prize. Fusion power offers a nearly limitless supply of energy, with no greenhouse gas emissions and minimal radioactive waste. It's an energy source that could power our world for millions of years and dramatically reduce our carbon footprint. Fusion power may not be here yet, but it's on the horizon. And when it arrives, it'll change the world as we know it.